Before we kick things off, I've got two quick things for you. First, do you want to push real innovation and help spark the uncomfortable but necessary conversations in the concrete industry? Support this show. When you donate, we list you as a producer of the episode because you're literally making these conversations happen. Go to concretelogicpodcast.com/donate and back the show today. Second, for a limited time, you can get free access to the Concrete Logic Academy. Take your first class on us, earn a PDH credit, and stick around for the networking and resources you won't find anywhere else in the industry. Claim your free trial now at concretelogicpodcast.com/academy. All right, let's get into today's episode.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandett.
And welcome to another episode of the Concrete Logic Podcast. And today I have three gentlemen with me from Silverback Concrete. Frank Stankunas, he's president. Frank Stankunas Jr. is vice president. And James Cordeiro, director of strategic development, is with me today. And we're going to talk about thermal resistivity in concrete for data centers. This is a new topic for me personally. I've ran across it on projects before, but these fellows have been doing it for a while, so they got a lot of share, and I promise you'll learn something today. Before we get into the topic, I just want to remind everybody to support the podcast. You hear the introduction, the lady tells you the couple ways you can support, but you need to hear it from me because you haven't heard it from me in a while, is to make sure you go to the concretelogicpodcast.com website. You can donate to the show. And when you donate to the show, it's like you're sponsoring or producing the show, and I will give you credit for doing that. Your name, your company, or you personally will be listed attached to that podcast episode, and that'll be attached there for life. So make sure before you donate that you want your name attached to this podcast for life. And then make sure you check out Concrete Logic Academy, concretelogicacademy.com. That's a good way for you engineers out there to get your PDHs so you don't have to do those boring courses that are out there. We all know what I'm talking about. You can sit there and a guy sits there and reads PowerPoint for an hour. So if you like listening to this podcast, the Academy's for you. So check that out. All right, fellas. So we're going to talk about thermal resistivity in concrete for data centers. Who wants to tell us what that is and what that means?
Well, thermal resistivity is how easily we can dissipate heat from the electrical power lines that are running from these sub-power stations to the data center. So the idea is to remove as much heat as possible so the data can transfer quickly, so everybody can stream their Netflix and everybody can store their photos on their iPhones or their Android phones quickly and seamlessly. So it's really what we're trying to get at here. How easily and efficient can we transfer power and remove that heat? Because a lot of heat is generated from these power lines. So we have a cool concrete that can help dissipate that, and it's also related to the soil for these power lines that are run into these data centers.
Yeah, so that's kind of opposite of what we kind of think about when we think of concrete, right? Because it's kind of thermal, keeps everything in. So what you're saying is that you design concrete that lets the heat dissipate.
That's right. That's right. Yeah. Frank Jr. is the engineer behind this, and he can explain in a little more details. But generally speaking, yeah, you think about it. Concrete is a good conductor of cold and heat. but there's a special sauce that you can utilize in a formula that'll help dissipate that heat in an efficient way. And it's very important now that these data centers are drawing so much power off the grid. So anything we can do to reduce the friction on that grid is super critical, especially with all of these data centers that are being built now.
So can we compare like a standard, mix to what you all are doing as far as I guess we would call them targets, right? What's the measurement for thermal resistivity, I guess, to start with?
You want to answer that?
Yeah.
Your target is for low row. Typically it's 55. 55 is your low row. And the higher the row, the more it's conducting heat. The lower the row, the more it's dissipating heat. So if your normal concrete's going to be sitting around anywhere from 70 to 120 row, depending on where you are in the nation. Your low row, you're targeting 55 or under is what your goal is.
Okay. And like I said, this is all new to me.
Yeah.
Junior, you're going to have to put up with my dumb questions. So you say row, what does that mean? Is that like temperature? What does that mean?
It's just thermal resistivity is what it is.
Okay.
So how resistive your concrete is to the heat.
Okay. All right. So
it's a mathematical formula.
Yeah.
There's actually a formula that exists. It's the amount of heat that's dissipated per volume in the concrete. So there's a measurement that's been generated, and they chose a fancy term, Greek letter rho, which is where the term comes from. Looks like a lowercase p, but they pronounce it RHO, right? So you'll see that.
Yeah. I did a quick search on this. Like I said, I read up just enough to be dangerous. So okay, so why?
I would like to add, the lower the row value, the lower that number, the less resistance on the power grid, which is and your power bill comes down. It saves, we're saving 10 to 15% of a power bill on a data center by using a low row concrete in the 30s. If they have a 55 and we come in, Trace, what we hit in Virginia?
We have some at 29. Some of the
29, man. 29. So we're helping the grid. That's our whole goal is, you look at the grid and you hear about it, you read about it every day. We could talk about it right now. The towns don't want these data centers because of the power consumption, and we're helping the grid. That we're saving money for the owner. That's a fact.
That's cool. That's what I was going to ask y'all. Why is this so important for the heat to dissipate from these? It sounds like it's makes the power more efficient, is what you're saying?
There's several reasons why it matters. So there's two things. It reduces the power grid. The restraint on the power grid is reduced. It's also extending your cable life. So if your cables only have a certain many years of life expectancy, and increase the life expectancy of those cables, and also you're reducing your construction costs so for instance, if your soil, the deeper you go in soil, naturally, the lower row you're going to get. If you're in a wet environment, a moist environment, and it's compacted well, you're going to be around 60 for your natural soil. Your dry soils will be around 120. Your average in America, which it's hard to say average because, where are we, is around 90. But the deeper you go on your soil, the deeper you go with your duct bank. So if you're digging 20, 14 feet, you can save a lot of construction costs by using a low row concrete by only having to dig 5 to 10 feet instead of double what you're doing.
Yeah, that's really cool. So how do they test and verify the thermal resistivity of a mix? How do you do that?
Yeah, we have a third-party engineering firm. So what we do when we go out to a new market is we go and we scour the area for one of the best raw materials we can use within a radius of that particular market area. And then we partner with a third-party engineering firm where we go and Frank Jr. and the team design a mix based on the conditions of that area and the raw materials available. And then they do their pressure testing and they do their stability testing on that material. So it'll be specifically designed for that particular market to handle the soil conditions and the climate conditions of that area, and then the needs of the power that are being run from these substations out there. So it's all under the guidance of, in this case, Silverback, but in partnership with a third-party engineering firm, because that's how we're going to establish this as the path going forward to utilize these low-row concrete, because this is something the industry is aware of. They're aware of row as being a factor in this, but it's not quite there yet as far as being the standard on what's utilized in the power transmission, because we transitioned from what people are accustomed to in data centers knowing about storage. Data centers been around for a long time, but it's been more about where we store information and what's commonly known as the cloud. Where do we store it in the cloud? It's not physically a space in the air where the stuff is stored. It's just redundancy, or multiple data centers will have the same data stored in different locations, so you can preserve kind of in case there's any issue with one. But nowadays, with all of this artificial intelligence and the agent AIs that everybody's becoming more familiar with, ChatGPT and Grok and Claude and Perplexity and a number of other companies that are utilizing these actively engaged, artificial intelligent agents that are processing information, the power draw is dramatically increased. So the amount of power that's needed is substantial. So we having this new mix designs specifically catered to the markets in the areas based on the soil conditions and the raw materials. It's a game changer. And that's when we came up with this and Frank and his team did it, that was what we ended up naming it, because we think it's a game changer for the industry.
So there's not a standard for testing. Did I hear you right?
There is. Yeah, it's standardized testing across the board. We just need to draw from the locally sourced raw materials from the area and the soil conditions that exist in that area. But across the board, the engineering and the spec testing is standardized. Absolutely.
Okay. So how do they test it? If they're not breaking cylinders. So what are they doing to test the concrete?
Well, we use a company, SGS, which they're world renowned.
Uh-huh.
And so when we gather all the raw materials and we design these mixes, we might take 5 different sands from one region, 5 different rocks from that same region, cement, our secret sauce that we add to it, and then we start playing with the formulas to test the low row to get that region. Like when we went out to Phoenix, we're at 39 RHOs that people don't even believe us hardly, because we just didn't grab the raw materials that was closest to our plant. We went all around in a 90-mile radius, grabbed the raw materials and took back to our lab in Lawrenceville, Georgia, and created a mix for that region. How they test it, they've got all these, they test the way it's curing. They test the way the dissipation of the heat. They've got all these high dollar. It's a laboratory, man.
Yeah.
That they test our concrete on, and there was only one that even competes with us, and it's a slurry mix. It's not even a concrete mix. It's like a flowable fill.
Right.
And we're at a 3,500 PSI concrete mix, and then we throw the red dye on top, or either blend the red dye in with it. 50 years from now, if they go to hit those power, somebody's digging it up or whatever, and they see it, they'll know it's danger.
Yeah. So you mentioned about curing, do y'all need to cure it a special way? Wet cure these duct banks or anything like that?
No, it sets up just like a footer would set up. It'll cure just it would cure.
Now, there's a lot in that. So you have to control, you have to control your bleed water the density of your concrete matters, your hydration, your moisture in the concrete. All of that, there's a special formula to try to meet this row, right? So that all does matter. Absolutely.
Okay. So is it, are you trying to make the concrete more dense or less dense?
Denser has a better row.
Okay.
That is yes.
And I think y'all make your own concrete. right? And you
Yes,
place the concrete you make. How do you make sure that the concrete that is delivered is what you need for that duct bank?
Yeah, I'm glad you said that. The quality and consistency of your concrete is very important. There's a big reason for that. There's something called thermal runaway in your wires, your cables. So thermal runaway is when you have, let's just use soil, for instance. If you're going from a compact wet soil at 60 row, and then you have a dry spot at 120 row, well, all of your heat in your cable is going to be focused where? It's going to be focused in the 120 row region. So same thing with your concrete duct banks. So if your concrete is row consistent, and then you have a bad truck in there, or you have a bad mud, or you place non-row concrete in this duct bank, all your heat's going to be focused in that one area. So your quality control team matters. Your water cement ratio has to be on like a true water cement ratio, not just what the plant says. The true water cement ratio matters. The temperature of the concrete matters. When it was loaded, when it was batched, we just won't batch concrete if it's too cold or if it's too hot for row concrete. So there's a huge aspect and formula to this whole ordeal.
I gotcha. So high quality control standards for this
Yes,
mix.
sir.
I gotcha.
But Seth, here's what one of the problems we see in the industry is it's a copy and paste approach, man. You know, these engineers, and no disrespect to them, but they're so busy on the backlog of business that they're just copy and pasting these, you know. I mean, we went out to Phoenix and we're telling these guys that we know are having issues, and they're not. I mean, I don't know if they don't. Some of them don't even know what road means, man. And they're the engineers on the plans. They should know what low row means. They should be looking at ways to, I mean, we're trying to reduce the grid. And I was talking to a CEO of Ori Electric, and he did a thesis on this, and he's talking about, Frank, they need to take 3-phase power, spin it together, run it through the duct banks, the way they do the conduit placement, because then you could reduce the heat another 15% by doing that. Those are the things we need to be talking about and need to be educating and need to come up with, because if I'm telling you we can take off 10 to 15%, the way they put the wires in the conduit and place the conduit in the duct banks is another 15%. What does that do for the grid?
Yeah. Yeah.
You're going to give me a Pulsar piece of award, man.
Yeah. Yeah. Hopefully less windmills and solar panels.
Yeah.
So that leads Frank, that leads me to I was getting to this question. So who usually specs the row on the job? Sounds like you guys are doing more educating than them educating you on what needs to happen on these jobs. Are they copy and pasting what they had from job to job, or?
Yes, sir. So typically on all the submittals and mix designs that I've seen, that in their specs, 55 row is what they want. They want a 55 RHO.
I think it's 65, and
it depends on the region. So yeah, it depends on your region. East, you're looking at 55, 60, and then west, you're looking at 65, 60.
And it
is a copy paste. It's a copy.
Is it coming from the electrical engineer or the structural engineer? Where do you find that in the spec?
I've seen it on both, actually. It's coming from electrical engineers and the general engineer.
Gotcha. We're just pouring duct bank, but as the row gets lower, is there any impact on workability of the mix?
Of the mix itself? No. Not at all. Yeah.
No issues.
It'll look just like normal concrete. Now, typically you're going to want to pour it at a 3.5, 4-inch slump is what I like to stay between for us. But you know how these guys are. They want to add 20 gallons of water in it, and you just can't do that.
Yeah. And are you truck dumping? Are you pumping it, or a little bit of both? Or?
Do both. Do both.
Okay. I assume the lower the row gets, the more expensive it gets. Is that a true statement?
That is a very true statement. A lot of it has to do with expensive aggregate that's, trying to reducing heat aggregate. So aggregate that dissipates the heat rather than controls the heat and holds that heat in.
Yeah. And getting to the point of that is, the upfront construction costs we can impact. Yes, the price of the concrete is higher, but the amount of concrete could potentially be less. So it's an offset in that case. So we impact the construction costs, but we've also been talking about the long-term, recurring expensive of utilities on this. We're impacting that side of it as well. So as Frank was saying about a way to work with the cables to reduce the thermal resistivity as well as the concrete, we're impacting it in this way. So it's something we're talking more upstream now when getting into the building specs with this concept and working with the engineers beforehand. We've been pulled into these conversations now because of the work we've been doing with our partners in Virginia and getting really good feedback that this is an important conversation to have more upstream to bring this concept of row and potentially doing something better or something novel, right? Because I love the name of your podcast. It's Concrete Logic, right? So being logical about this, where do we start? We start with the basic principles are, why are we doing these things this way? Well, I don't know. It's just been done that way. Well, that's not a good enough answer for me. I want to know the real reason. Is that the right way? Is that the best efficient way we should be doing it? So it's what the team does here and why we've, been able to come up with this. But being involved in, those projects is really, really opened up, the conversation in this and it's worked out really well for us to expand our operations now out to the Southwest, which the soil out there, if you don't know, out in the high desert out there in Arizona, the soil is very dry out there. So the fact that we've been able to work within that environment and generate a similar row as we did in Virginia is a very good sign. And people are becoming more aware of it as we're able to have these conversations.
So Seth, and another thing to piggyback, if you look at a set of plans, most of the three-phase wire runs parallel to each other. We feel it's creating more heat. What we would like I'm not an electrical engineer, but they need to do some tests because we feel if you take those three-phase power, twist them together, that the electromagnetic fields, by doing that, it will offset and cancel each other out. And then that way, if you cancel the heat, then that's where you're going to pick up your savings. Less heat. Faster flow.
Yeah. Because we're definitely we've been talking about power here, but the real thing we're talking about is telecommunication. So the actual transfer of data, information, that's where we're trying to hit with these power savings is that the latency, this term called latency, which is how fast something can pass through these cables. So there's not a delay, right? Because I made a joke earlier about Netflix or our phones and everything, but so many things are controlled by these software programs. So we don't want to lose anything in the transmission of that data and information, because our power grids, our utility grids, our airplanes, our cars, our infrastructure is all run by these systems now. So it's a mission critical, as you I'm sure you appreciate being in the concrete world and data centers, that this is the fifth utility. The way that it's being described now, these data centers are actually a national utility. So it's a priority that we focus on being the most effective and efficient to maintain. These are operating 2365. They're never offline.
It sounds like from the success y'all had thus far is because they have, I guess, told you what row they want, what low row they want. And y'all come up with your mix design based on that requirement versus a prescriptive design, which they would tell you what to put in the concrete, right? With that experience so far, it doesn't sound like there's not an ACI standard for this, right? Is that correct?
So Seth, there it is. We were in the specs. It's a 3,500 PSI 55 RHO is what they want you to hit.
Okay.
And so we will make that mix because it's less expensive if the owner hasn't gotten the news that, hey man, then we'll make them two mixes. We'll make them just one for specs, and then we'll make them our game changer mix. The game changer mix, it costs us more money, so it costs the owner more money. But the fact of the matter is, it really saves them money in the long term. If we save 10% of a power bill or 12% of a power bill a month, what does that look like on a 46 megawatt building?
Yeah.
Then you times that times 100. That, we should double the price of the low-road concrete. I mean, that's astronomical amounts of savings in the long run. Initially, it costs more money, but the wear and tear on the wires, the power bill for the next 40 years. I mean, we said so it's a two thing here. We're saving real money to the owners by using a low road concrete. Less heat, better problems, man.
Yeah, no, this was very eye-opening for me. Like I said, this is new to me. I haven't spent a lot of time on learning about the resistivity of concrete. It's usually like, hey, that duct bank stuff is for the electricians, right?
Yeah.
Is there anything else you guys want to share before we wrap it up today?
Well, I would just like to encourage these somebody, an engineer, to really look at the conduit placement, the electromagnetic field cancellation, the way we backfill. I mean, EMF is electromotive force and electromagnetic field. I mean, those are, so electromotive force, it's the energy per unit charge supplied by a voltage source to drive electric current. And the electromagnetic field is a combination of the electric and magnetic fields. I mean, this is all high-tech stuff, but if we could somehow, let these wires offset each other but when you run them parallel, it's creating a lot of heat, man. It's a lot of heat in that duct.
Yeah.
And somehow, if the way we place the conduit, now it's, they're big studies. I mean, we're just having a little podcast here, but
I know. Yeah. And Seth, I want to thank you for giving us this opportunity. This is, really cool that we're able to talk to you about this. And, what we're really looking to do is build long-term strategic partnerships, with electrical engineers and architectural engineers, right? Mechanical engineers, as well as the GCs and the owners on these buildings. We like to have conversations and see what's possible, because I told Frank, he may not believe it, but I think he's becoming we're a bit of a tech company. We've got technology here that we're working with, and the concrete industry is the second most utilized resource in the world next to water. So concrete is a very important component of our society. And so if there's anything we can do to bring all of the players together, discuss, well, what's a better way to build something more efficient and effective, especially during this new race, right? There's essentially a new race with the race to achieve artificial intelligence and be the kind of the world leader in this. And United States is in a good place to be that leader. But we got to work together. And that's always what we're looking to do, is how do we build strategic partnerships throughout the U.S. so we can get the message out, and we can get other people more familiar with the possibilities of working with something like Silverback's, game changer, cool concrete mix design. So we're happy to have a chat if people want to reach out, and we can share contact information with y'all and have it in the notes there as well.
Yeah, I'd be really interested to see the savings or the power efficiency from standard, whatever spec to what you all come up with, and the savings, the energy savings there, which again would roll right into, reducing the carbon footprint of a data center, which is what all these data center owners are concerned about. On top of what you mentioned earlier was the energy use that the data centers have and how that impacts the surrounding communities. Everyone's worried that data center drops, near their home, that their electrical bill is going to go sky high. I mean, again, it's this is, like I said, I thought this was a great episode with you guys. I think there's a lot more to talk about, and we could get some other folks involved and have a more expansive conversation on how this can help not just the data centers, but the community itself. With that, Frank and Frank Jr., do you guys want to share how folks can reach out to you, learn more?
So I'm Frank Stankunas. They can catch me by my email. It's fstankunas@silverbackconcrete.co. And that's my email address. That's probably the easiest way. Seth, I would like to say that one more thing is we would be willing to license this. We'll go to a region. We don't have to just move a plant there and take over. We will go make a mix design for that region and then let them run our mix designs. We would do that for, anywhere in the United States. We're looking at a couple of locations now. And that's not that I'm just going to come over there and put a ready mix plant, take over the job. We will come over there and make a mix design and then license it to the local ready mix suppliers. We will do that.
That's a fantastic idea. Frank Jr., how do we reach out to you?
Yes, sir. So my email is pretty much the same. It's Frank Stankunas Jr. at silverbackconcrete.co.
Stankunas.
Yeah. Sorry. Correct.
Don't worry.
F. Stankunas.
Don't worry about it. I'll get it right.
At silverbackconcrete.co.
I'll make sure I get it right in the show notes. James, how about you? How do they reach out to you?
Yeah, we have the same format. So it's my first letter, my name, J, and last name, Cordeiro, at silverbackconcrete.co. You can also check us out at silverbackconcrete.co online as well. We have a website set up there and some social media presence through the website.
Yeah, so I thought this was a great episode, guys. A great introduction into thermal resistivity of concrete and data centers. Appreciate you coming on the show. And folks, until next time, let's keep it concrete.